Good afternoon. My name is Nick. I'm the head of BD at xyzt.ai, and I will be the moderator today. So first of all, I want to thank you all for joining this webinar with our partner Bridgestone Mobility. The webinar is entitled Unleashing the Power of Data, Transforming Mobility with XYZ and Bridgestone Mobility Solutions. So before going through the agenda, I would like to introduce the speakers to you. So first one is Raghunath Banerjee. Raghunath is VP Data Solutions at Bridgestone Mobility. And second one is Bart Adams. So Bart is the founder and CTO at xyzt.ai. Before taking you through the agenda for today, I would like to mention a few points. So for some interactivity, we will ask you some questions during the webinar, so feel free to answer those. If you have any thoughts or questions, you can always ask them via the chat. We will try to come back to those during the Q&A at the end of the webinar. If not, then we will definitely reach out to you via email. The webinar also will be recorded, and the recording will be shared with you as soon as possible after the event. So for now, please mute yourself and listen to the webinar. So going through the agenda for today, we will talk about 4 topics. So first point on the agenda is our opening story. We always like to start with some paradoxes to set the scene. Second point on the agenda for today is about a partnership. So there, Raghunath will talk about Bridgestone and Bart will talk about XYZ, and they will both elaborate on the partnership between Bridgestone and XYZ. Third topic for today is use cases and demos. So I think it's the most important part of the webinar today. So we will talk you through some of the use cases we have encountered and show you some demos on the platform. And then the fourth point for today is how can you get involved yourself? So how can you connect data and how can you start working with the xyzt.ai platform? So for now, I will hand over to Bart, who will start with the opening story.
Okay. Thank you, Nick. Thank you all for joining. And also a big thank you to Raghunath and his team for going on this journey together with us. I like to set the scene a bit with a few paradoxes, some of which probably you already know, and maybe some are new. First one is a very old paradox, and it's maybe a surprising one, but it's also one that has been contested a little bit. And it's about the fact that if you drive slower, it's not necessarily safer, meaning that if the traffic around you has an average speed, and then you decide to go slower, actually the chances of getting into a collision are becoming bigger. This is a very old paradox, and there's been many, many studies about this. But the idea is quite logical in a sense. If you drive slower, basically more cars will pass you. So you will be in the possible situation to be in a crash more often. So a paradox, but this is one of the paradoxes that makes that traffic management is not an easy task. The second one I want to highlight is Braas's paradox. So Braas, he found out that in a road network, when you add a new road, basically, for example, if you want to have a better flow of traffic going from city A to city B in this network, you could decide to maybe add this new link. Well, what Braas showed is that not necessarily this new road will improve traffic flow. On the contrary, it might even happen that traffic flow becomes worse. And there's all types of mathematical reasoning behind this, why this can happen. But the main logic is that people will start using the new road because there's not so much traffic on it. But then people that would not take the car or maybe would drive differently, they would see that the other roads become less congested and they would enter the whole traffic flow as well, leading to, in the end, more congestion. And now the paradox here is not in one way, it's in the other direction also. Sometimes if you close a road, it might happen that traffic flows more smoothly, which is really strange to reason about, but there are instances where this actually happened in the past. And then the final paradox is maybe a paradox I made up myself, but it's a very modern one. And it's something that we encountered when we go on a trip with an electric car, we see that the infrastructure is not ready. So the paradox here is we are forced to electrify our fleets, and we see it with the company cars in Belgium, for example, but it's also going to happen with trucks and logistics companies. We're forced to electrify, but the infrastructure is not ready. And there's actually some really nice research about this. And I just took one from Grigorev and his team, and they showed in Australia for a certain road network that if only 0.15% of the predicted electrical vehicles would stop at the recharge station in that network, it would lead to wait times at the charging stations of over 2 hours in most of the stations. And this is, of course, not acceptable at all, and it will not drive electrification in a positive way. So the reason why I want to start with these three paradoxes is just to state the scene and try to explain that traffic management and the whole mobility problem is not an easy one to tackle. Now, luckily, over the past years, there's been a lot more data. And that's what we want to convey today. Data gives you, as an analyst, superpowers. And imagine what if you could analyze the distribution of driver speeds on the roads in your city, in your state, and you could do this on every possible location at every time of the day. What if we could predict where crashes were likely to occur just from looking at data instead of having to wait until a crash actually occurs in a certain corner or a certain traffic area? What if you could monitor travel times? So say you decide to close a road, and then you have monitored travel times before, but also after the closure, and then you can start comparing and analyzing. What if we could find optimal charging locations just by using data? And what if we could do this for every possible location in your area all the time? Today, with data from yesterday, looking at data from the last week, last month, last year, and so on. And this is possible thanks to data. And this is why we are on this journey together with Bridgestone Mobility Solutions on bringing this data to analysts. Before going into this, Nick, I want to introduce you to the first poll question.
Yes, thank you, Bart. So the first poll question for today. What data sources are you using now? A, open data, B, traffic counting data, C, floating vehicle data, D, I'm looking for good data, or E, other. So I would like to invite everybody to vote. Couple more seconds. Okay, so everybody voted. Okay, so looking at the results, we have a lot of people who are using open data, a lot of people using traffic counting data or floating car data, but we also have a lot of people who are looking for good data. So with that, I would like to hand over to Raghunath.
Thank you, Nick, and thank you the entire XYZ team for inviting us. And this is a great initiative to strengthening our partnership. So Bart already mentioned the superpower of the data. Let me give some concrete example that how within Bridgestone Mobility Solutions, we are unleashing the power of the data and creating new data solutions for the entire mobility ecosystem. But before we deep dive, I think it's important to understand the evolution of the Bridgestone Mobility Solution. I think all of you know Bridgestone is the leading tire and rubber manufacturing company, founded in 1931 in Japan. And the core DNA is serving the society with superior quality. But in 1988, it truly became a global company with the merger of the Firestone. Now, after that, in 2020, we launched our global mobility solutions business to really empower the solution business, which is, we call it Bridgestone 3.0 journey. And that's where several tire-centric solutions towards a global ecosystem we are providing it. So this is a very exciting time for us, and this is an exciting journey towards the new challenge that we have. And we are really happy to enlarge and enhance the partner ecosystem for solving the complex problems that we are seeing today. Maybe the next slide. So coming from the tire background, if you really wanted to produce superior quality tire for your customers, and also understand that how your vehicles are driven, where the vehicles are driven, what is the condition of the vehicles there, it's very important to understand the vehicle intelligence part of it. And that's how 2019 Bridgestone acquired the Webfleet Solutions, which is the leading fleet management solution in Europe and also present in 65 countries. And then Azuka in North America. Now, if you think of combining these two fleet management companies within Bridgestone, then we have the access of 2 million vehicles. These vehicles are driving 2.5 billion kilometers per month, and also our global presence. Also, it is generating 16 billion data trust points per month. So this is a core asset, and every connected vehicle generating huge amount of data every second. And that is where within the data solutions team, we are leveraging this data towards creating several mobility solutions. Next slide, please. Now, coming from the Bridgestone background, we are the complete expert of the tires. And if you look at the tires over a period of time, this has also become connected tire products. We have several sensors now fitted on top of the tires, like tire pressure monitoring system, tire mount sensors. By virtue of that, we are able to detect the tire pressure, tire temperatures in real time. And also using our AI-powered models, we are also able to predict the health of the tire thickness, tire wear, tire damage towards the predictive tire maintenance. Now, if we add on top of this tire intelligence, which is our core competency, the connected vehicle intelligence, like driving behavior, the CO2 emissions from the vehicles, fuel consumptions of the vehicles, road conditions, where kilometers driven by the vehicles, then we can really create a very powerful ecosystem towards serving our customers in terms of efficiency, safety, and sustainability, and empowering our future mobility solution providers to make the data-driven decision-making process. And I think the survey shows that how many people are really looking towards the open data sets, how many people are really struggling to find the right data sets. And that's how I think we are very well positioned today to open the entire partner ecosystem with the complete tire intelligence data and the connected vehicle data to create new mobility solutions. Next slide, please. Now, when we talk about vehicle intelligence data, we have access to several sensor data from the vehicles, and which is every second we are monitoring them through the telematics systems. Now, using that, we are able to create several products. One of them is floating car data. I think all the mapping and navigation companies today are using this floating car data to predict the traffic congestions, real-time traffic situations, providing the value to the entire traffic ecosystem. Secondly, we are also capturing the hazardous driving conditions like acceleration, braking, and crash events. This is a very important parameter, and the events coming from our entire install base globally which cities are today using it for infrastructure planning, deciding if they wanted to enhance a bicycle path, which is the safest path. And that is where we are able to not only leverage the real-time data, but also historical big data that we are storing it to give a complete analysis that where exactly you need to extend, what is the safe roundabouts, where exactly the vehicles are overspeeding, where exactly we see the harsh braking and crash events happen. And that's really empowers them to take a data-driven decision makings and infrastructure planning for the future expansion process. Then we are present in several different install base like truck, passenger car, heavy commercial vehicles, lightweight commercial vehicles. And through that, we are capturing several sensor data that can predict the weather conditions. Like we are able to clearly identify where the vehicles are switching on the wipers, where the fog lights, tail lights are turned on. And if you combine the location intelligence on top of it, then you can clearly predict what was the weather condition on that spot. And then also the EV for the vehicles, where they are driving, how often they are charging, where the charging stations are located, and how the vehicles are used. So entire vehicle profiles we are able to detect it. That's very important for the whole ecosystem to take decisions and also create more advanced products from there. Next slide, please. Now, as all of you know that tire is the only part that touches road. So for Bridgestone, it is very important to understand the road conditions. So we have right now 4 different products in this road condition area. One of them is road damage detection. We are precisely able to detect the potholes, which is causing the damage to the tire, but also causing a lot of accidents on the road. Huge impact to the safety. That's one we are able to detect. Second, road roughness monitoring. We are not only able to identify the unevenness of the road, but also the specific segment of the road need to repair. So that's very important for the road authorities and roadside assistance providers to really understand and give an early prediction to this repair jobs. Now, also what we understand, if we kind of leverage the vehicle analytics and also the AI-powered vision powers from our camera devices, then we can predict or we can detect the road traffic conditions like traffic lights, speed signs, road work conditions, and that's can give an early indication that what's going to happen or what is happening in these areas. How can we manage the traffic better? And in combination of these things, it brings the unique road safety features. That is what is very important for us today. Also, we are able to detect the grip because we know the road frictions. We are also able to detect the slipperiness conditions. So these are the things all coming from our 2 different install base. Like one is our connected tires, intelligence from the tires, but also the vehicle intelligence data. Next slide, please. Now, I talked about many different individual products or insights that we are able to create today. Now, if you think of the requirements of the future smart cities, and if we kind of superimpose these individual elements towards the requirements of the future smart cities, then we think that we are able to really predict a lot of insights and also a lot of challenges today, solve those challenges because we know the pavement marking, we know where the inefficient traffic signs are, we know where precisely the identifying dangerous roads conditions, we know the road damages where exactly happening, also the road roughness measurement, CO2 emissions, which areas or which time of the area we see that specifically the CO2 emissions from the entire city goes up because there are a lot of vehicles are going on that area. A lot of heavy commercial trucks have been driven on this area because there are cities who are taking decisions now to prevent the heavy commercial trucks entering this thing. It's a huge, important decisions for them to make it, but how do they take this decision? And that is where we can provide these insights, where several digital twin platforms are today enabling these solutions or making the decision different. Then also in terms of the winter conditions, there are cities who are really suffering from slippery road conditions. Several accidents are happening. Can we detect that? Can we really, real-time basis, identify this and provide this information to the all mobility providers? Yes, that is possible. But within Bridgestone, we believe that we cannot change or we cannot solve all the problems. So partnerships and co-creation is a very important aspect of this thing. That's what we are partnering with several of them, including xyzt.ai, in this space to change our future generation mobility. And that's what we see, that truly unleashing the power of the data, we can make the future mobility leaner, greener, and safer. With this, I would hand it over to Bart.
Thank you, Raghunath. So now that we've seen about all these really cool data products, so why xyzt.ai? So why do we exist? What's our why? And basically around 3 to 4 years ago, when Lida and I started xyzt.ai, we saw that there's so much data coming. There's so much data coming also from IoT devices, but also from connected vehicles. But we saw that there were no real good tools that could handle this data. And people would start using data science workflows. They would hire data scientists and they would crunch the data, build their algorithms, and so on. What we saw by interviewing those organizations was that those data scientists typically take quite a long time to get insights when they get a question to solve. And also what we saw in bigger organizations, that typically there's only a few data scientists that have to cater to all the different business units, which makes that they become the bottleneck. And that's what you see here on the diagram. So we wanted to basically empower the different business units, the analysts, to be able to use this awesome data. Now, if you look at a data science workflow, this is what it looks like. Basically, you have to be able to connect to the data. You have to have scalable storage because the data is really big. You have to build algorithms, then you have to use visualization toolkits, for example, to visualize the data. You have to validate what you're doing. You have to iterate and improve. Then you can build dashboards. You can deploy those dashboards and you can hand over the dashboards to the analysts. And only then you get to extract insights. And typically what we saw is that this workflow takes weeks or months before you get to the insights. And this is what our mission is. Our mission is to take those 6 steps out of this long cycle and reduce it to 3 simple steps. Basically, you get the data from Bridgestone, for example, you ingest it, you connect it, and immediately you can start analyzing day 1. You can start analyzing and extracting insights. And not just for you, but really for your stakeholders, maybe your colleagues, your customers, maybe the press, the politicians, and so on, to share those insights. And that's all what xyzt.ai is about. And I'll be giving a couple demos later. I just wanted to show you this little screenshot of one of the analytical pages in the platform. So you will see it's very map-centric, it's very data-centric, it's very visual, and it is very interactive, because that empowers really analysts to become an analyst rockstar, like we like to say. That brings me, before I get into the use cases, into the second poll question. Nick?
Thank you, Bart. So second question for today. Are you using a self-service analytics solution? A, yes, Power BI. B, yes, Tableau. C, no, I'm mostly using Python. D, no, but I need a good solution. Or E, other. So the vote is open. So I would like to invite everybody to vote. Couple more seconds. Okay, thank you very much. And here is the result. So most of you are using Power BI. Some of you are using Tableau or Python. And there is also some of you who are looking for a good tool. So with that, Bart, I think you can give some examples on a good tool.
Yes, and I'll try to convince the Power BI and Tableau and Python people. that they can be much more efficient by leveraging our platform, of course. So I want to show you 3 different use cases today. And really the goal is to show you what is the art of the possible. By no means I'm going to show all the possible functionalities because it's going to be maybe too much. So the first one is what we like to call an on-demand traffic analysis and reporting. So basically imagine you get a question, maybe from the press, and you have to do the research, analyze what is going on and report on what is going on. And ideally, you like to do that as quickly as possible. The second use case I want to show is a use case that is a bit outside of the traditional mobility and traffic analysis. It's a site location selection use case, and it's all about finding the optimal location to invest in EV charging infrastructure. And this relates back to the third paradox at the beginning. And then the final example I want to show is a road safety analysis, where we will leverage the ABC data, so acceleration, braking, cornering, events data, to do an analysis on where to focus your efforts first, to basically address the most critical parts. So I'm going to switch to the platform and I'm going to take you through those 3 different use cases. And later on, I will also point you to where you can do these types of analysis yourself using the data. So I'm going to switch to my browser. This is the xyzt platform. I'm going to sign in and I'm going to end up in my own account. Just put it on full screen here. So basically what you see here is, and it's a web-based platform. It's multi-user, so you can use it with your team. You can log in with multiple people, work together from any device, from any location. You could even work on your iPhone or iPad if you want. What you see here is the project's overview, and you see I prepared a number of projects here with data from Bridgestone, and I'm going to take you through those different projects. Here on the left side, you will see some UI to basically manage those projects. You will also see some UI here to manage resources. And for example, in all those different projects, you will see there's a data set, and that data set is the Bridgestone data set used for that project. And then here in the middle, you see different analytical capabilities. I'm only going to highlight 1 today or maybe 2, but it includes visual analysis, trend analysis, analyzing segments in your data, distributions in your data. There's origin destination analysis, there's dwell time analysis. So many different capabilities. What I'll do first is I'll switch to this one. It's actually sample data that we also have in the platform for our trial users to try out. And this is about the Bridgestone traces data. So what you see now is basically 1 month of traffic. And as you can see here on the right, it's mostly heavy traffic, so trucks, and there's a good reason for that. There's LCVs, which are light commercial vehicles. There's, of course, passenger cars and so on. So this is what we call visual analytics. You're looking at the data from a certain point of view. You're looking at the data on the map, you're looking at the data on a timeline, and here on the right side, you're looking at statistics about the data. And our platform is built to do really on-demand analysis, meaning that you can basically zoom in on an area, filter certain data out, zoom in on a certain time range, maybe do a side-by-side comparison and find what you are looking for. So imagine in this case that I'm an analyst working for the city of Antwerp. And for those of you who know Europe, Antwerp is actually the 2nd largest seaport. Actually, it's a port that is inland, but it is a seaport, and it's actually a very important one for the continent. And as a result, there's a lot of traffic, really a lot of traffic, a lot of heavy traffic. Now, the first question I get is, okay, how does that relate to the overall traffic in Belgium? How does that relate? So for example, I'm looking at this area now, which is the Antwerp region, and here on the upper left side, you see the port area, you see the different port terminals. And here you see a heat map of traffic. And white means there's a lot of traffic. Blue means there's less traffic. That's basically what the scale is of the heat map. Here on the bottom, you see a histogram. You see some patterns there. You see the weeks coming back. You see the weekend coming back. Of course, in the weekend, there's going to be less heavy traffic, commercial traffic, and so on. And here on the right side, you see the number of trips. And a trip is defined as a movement of a truck or another car or vehicle between point A and B with all the intermediate GPS locations. So that's what a trip is about. So behind the trip, there's already a lot of data. In this case, I enabled a couple of properties in the platform. There's like a speed property, there's vehicle type and road type. So as a first step, what I'm going to do is I'm going to analyze not just what is happening in Antwerp, but I'm going to relate it also to what is happening in the entire of Belgium. And so what I'm going to do is, because I'm interested to dive deep into this congestion problem in Antwerp, what I'm going to do is I'm going to split my map. So I'm going to click on this plus button on the top right, and I get a second map. And you will also see, I'm going to try to hide my zoom buttons here. So I'll make it a bit smaller. I'm going to basically make those two maps independent of each other. So basically what I'm going to do is I'm going to zoom in here on the left, just on the Antwerp region. And I'm going to zoom here on the right. Basically, I'm looking at the entire of Belgium. Now, what you see is, if you look at all the trips in Belgium, there's around 300% more trips than in the Antwerp region, which doesn't sound like a lot more. So basically, this means that if you look at the total number of trips, that Antwerp is seeing about 1/4 of all the truck traffic in Belgium from this sample from the global data set, of course. So this is the first analysis that I did, is saying, okay, Antwerp can be pretty bad in relation to truck traffic. Now, the second analysis I'm going to do is I'm going to look into the congestion. And this is actually the main ring surrounding Antwerp. And if I zoom in on it, you see there's quite a bit of trips passing through this area. What I'm looking at now is just the density map. It's just telling me how much traffic there is. And you see the time range is still the entire month. So what I'm going to do is I'm going to switch to a different visualization. And instead of looking at the density map, I'm going to look at the speed profile. So I'm going to enable speed. It's set to a color map. You see it here from red to purple between 0 and 120 kilometers an hour. And if you look here on the right, you also see a distribution of those speeds. Now, what I'm looking at is actually what I'm seeing on the map. So basically, you see this area here is also included. This area here is also included. Whenever I zoom in and out, you see that my statistics update. So it's always interactive to what you're looking at. So one thing I could do, for example, is because I have the road type, I could use it as a filter. So I'm going to select a property filter here, and I'm going to use road type motorway, which is in the Bridgestone data, which is super convenient to have. And I can filter out all the data on the secondary roads and the smaller roads. And now I'm really looking at what is happening on the highway. Just by looking at this widget, here on the right side, you see that the average velocity is only 56 kilometers an hour. And I believe in Antwerp, the limit is around 100 or 90. Correct me if I'm wrong, but it's around that area. So you see the average speed over this entire month is just 56 kilometers an hour. Now, what you will also see just by looking at the colors of the data, you will see that there's quite a difference between traffic going north and traffic going south on this area. So as an analyst, the first thing I would like to do is look into what is happening. What is the difference here? So what I'm going to do is I'm going to try to filter out traffic north versus traffic south. So luckily in the data, I have the heading, and you see there's two peaks in the heading. So I'm going to use another property filter based on the heading. And I'm going to use, for example, a filter like that. And then I only get to see traffic going south. And if I look now at the distribution here of these velocities, and you see there's a lot of variance. There's actually two peaks. There's a peak around 20 to 30, and there's a peak around 80 to 90. which means that there's a lot of congestion in this direction. And this is actually an indication that this is a dangerous area because there's so many variations in the velocity. Now, if I want to really see what is going on in the other direction, the only thing I have to do is basically do the opposite filter. And then I get to see what is happening in the other direction. And you see in that direction, there is less spread on the data and traffic flows with more constant velocity or constant speed. There's different ways to analyze in the platform. You can do density analysis, you can do comparison, you can do filtering, and so on. So for example, what I could also have done is I could have chosen a speed property and just look at when traffic becomes between 0 and 30 kilometers an hour. And you would see just from looking at the data, it's mostly on the traffic going south. So this is the lane or the direction that sees most congestion. Now, I was tasked to analyze the situation, but I'm also tasked to report on the situation. And that's built in the platform. So built in is really the capability to take a statistic, take a visualization, and report on it. So for example, say that I'm looking in reporting on what is happening in both directions. I could add a widget on the dashboard, for example, this widget, and I could say traffic south, and I just call this Ring Antwerp. So basically what I'm doing is I'm giving this widget a title and I'm putting it in a group of widgets. That's basically what I'm doing. I'm going to do the same with the other one in the other direction. So I'll also put this as a widget, put it in the same group, and I say traffic north. And this is how easy it is to build up a dashboard. You can do it with a map, you can do it with a timeline, and you build your dashboard like that. And then, of course, you can further configure your dashboards. And there's many examples in the platform on how to do that and what you can do. And from that point on, once I have my dashboard, maybe I can add some explanation to it. So I'm going to add some about widgets before I start sharing this. And I just say analyzing 1 month of traffic on the ring south versus north. I'll put it in the same group here, and I'm going to move this to the front, maybe make it a bit smaller, like this. And this way you can build up a whole data story or a report, if you will, and you can share it with anyone. You can click this button, create a shared link, and you get a link for other people to open this report. I'll just show you what it looks like. So if you send it out through email, for example, and they click on the link, they get onto this page, and then they can look at the statistics, look at the results, but they can even dive deep if you allow them and do their own analysis. So that's what is possible there. So this was my first use case, very simple, high-level analysis. I still have some few minutes for my second and third use cases, so I'll do that quickly. So the second use case was about using the Bridgestone traces data to find optimal charging locations. And for this one, I'm going to switch to a different project. I prepared the second project for this. And this is actually data. It's again traces data, so it's floating vehicle data, but only trucks. I only took trucks in this data set, and you see that here on the widget. And this is just 1 day of traffic through France. You could do the analysis with a month of data, a year of data if you want, but I'll just do it with 1 day of data now. And basically what I'm trying to find out is where do trucks meet mostly where they have traveled around 400 kilometers. So imagine that you are an EV charging company and you are looking where to invest in the next charging location. Then you can use the Bridgestone data to do that analysis. And I'll just do it like, just quickly show you how to do that. Basically, I have a property here, trip duration, trip distance, and also distance traveled. So distance traveled is an interesting property, and I'm going to use it as a filter. So basically, I'm going to switch to distance traveled and set it to around 400. So what I'm going to do is I'm going to take 450 and a lower one of 350, set it as a filter, And now it's going to filter out all the data, all the waypoints or GPS points, if you will, that are outside of this range. And we are looking at the heat map of that. Now, interestingly, on the timeline, you will see that most trucks will have traveled this distance at around 3 p.m. So basically, at around 3 p.m. UTC time in this case, you can expect basically, if all those trucks would be electrical, a lot of demand on the electricity network, if they would all go in and charge their trucks. Now, what is now the optimal location to invest in charging infrastructure? Basically, what I'm going to do is I'm going to look at the heat map again, and I'm going to change the color map a bit to make it a bit more descriptive. And basically, what I'm going to look at is at the areas with the highest density. And those are the areas where most trucks travel with this distance. I can see that on the map, and I can play with the color map. I can play with the color map to basically highlight certain areas. But what I can also do is, and I'm going to use it in the next use case as well, I can also filter out areas that have only a little bit of data. You see how interactive it is? And this way, I can basically narrow down my analysis to my top locations to do the investment. So for example, here in France, south of Paris, we see it would be a good location to invest because there's a lot of trucks reaching that mileage or that distance around this time. Final analysis I want to do is one with the ABC data. I really think it's an awesome data product. So just to reiterate, ABC stands for acceleration, braking, and cornering. And in this case, I think we took 3 months of data, which is quite a bit of data in Portugal. And what I'm going to show you is what the power of this data is. So now we just again see a heat map of all those events. You see most of them are cornering events. Some of them are braking. I'm going to do an analysis, for example, on cornering. So what I'm going to do is filter on the cornering types. There's actually 2 types of cornering events, cornering left and also cornering right. Put those 2 filters. You see, apparently most are cornering left. And for example, if I'm now interested in analyzing which areas see most cornering events, I can do the same type of heat map density analysis. I'm going to increase my cell size a bit. So this allows me to use basically bigger squares, bigger areas to analyze. And then I'm going to erode the heat map again. So basically, I'm going to remove the cells that have low counts. And this way, I can basically see what cells have most counts. And I can keep doing this until I have a certain number of locations. So in this case, we see that this location here is a location that sees a lot of cornering events. So what I'm going to do is I'm going to zoom in on that location. I'm going to reduce my cell size again, reduce my count threshold again, and then I'm going to see what is happening there. And so in this case, you see that this roundabout is actually one where people are cornering a lot. So basically, it means that they take the turn too quickly or they go out of the turn easily. And this data can be used. You can filter on all those different types of events and do your analysis with this data, like I showed before. So that brings me next to the final poll question.
Yes.
Before wrapping up.
Yep. Thank you, Bart, for the demos. So final question for today. Are you interested to find out more? So the answers can be A, yes, you are, and you want more info about Bridgestone mobility solutions, about their data products. B, about the xyzt.ai platform. C, about both. Or D, I'm not interested for now. Okay, couple more seconds. Okay, thank you very much, everybody, for voting. So now, before heading into the Q&A session, Bart, I will hand back over to you to explain how they can work with the platform and the data themselves.
Yes, thank you, Nick. So I hope you enjoyed the examples. I know it was very quick and maybe a lot of information, but please, you can get involved yourselves. And basically, it only takes 3 easy steps. As we explained, obtain the data. It can be as a historic data dump, like weeks, months, years of data, or it can be a recurring data drop. For example, every day, a new data set for a certain country, certain region. Second step is to connect it to the platform. It's as simple as basically drag and dropping it, or if you can script with APIs, you can use the API and automate the data ingestion. And then finally, from that point on, you can do your visual analysis. And this is really where we see our users. They basically compress their analysis time really from weeks to days to minutes to get their insights out of the data. So that's the third step. So for the data, I would really kindly like to refer you to the team of Raghunath at Bridgestone Mobility Solutions, and you get the email address here. For us, you can contact us at info@xyzt.ai. You can also try for yourself. The link is here, platform-xyzt.ai. Log in, you get a sample data set with 1 month of data throughout the entire Belgium. It's a lot of data. And you can do the exact same analysis I did in Antwerp in the first example. So I would like to thank Raghunath still again for joining us. And I think that brings us to the Q&A.
Yes, thank you, Bart. So we have received a couple of questions over the chat. One of the questions that came up was, and I think it was with your second demo, Bart, people were asking how many vehicles do you have in that data sample? So I don't know if you can answer this on the spot or if you need to get back to it.
I probably need to get back to it. Let me see. So this was 1 day through France and around 18,000 trips. Yeah, so around 18,000 vehicles. Yeah.
Then I just received another question, which is also related to the coverage. So maybe that is a question that Raghunath can answer. So the question is, what is the typical coverage rate of your floating car data?
Yeah, I think I will answer it in 2 areas. First of all, our geographical coverage and how do we sample the data. So geographically, I think every parts of the Europe we are present today, and we can capture the data because in our install base, we have the commercial vehicles who are driving a lot of kilometers. It's not the passenger cars or personal cars. Then beyond Europe also, we are present in North America. You might have seen in the heat map, South Africa, South America, Australia, and New Zealand. That's the kind of areas that we are looking. Secondly, we have 2 ways to do that. One is that we can capture also high frequency data from the vehicles on demand basis, depending on the analysis that you are performing, which can go up to 1 Hz. And also we can capture the normal 5 positions in a minute. That's also we can capture it there. So we are very flexible because the install base and the telematics hardwares that we are using that we can leverage, that can be programmed to extract different frequency of the data for the different regions. So that's how we are operating with all the partners on on-demand basis. And because the requirements from the different mobility sectors are very different. So we all need to be very flexible in terms of the data sample sets that we are providing. We also have batch, we also have streaming options. So real-time traffic providers who are really looking for on-time solutions, we also do a streaming. I hope that answers your question.
Thank you very much, Raghunath. Bart, then maybe a question for you still. What if I have both sensor data and floating car data? So basically, what if I have 2 different types of data?
Yeah, that's a very good question. So in the platform, you can bring your own data. It's a very open platform. You can basically create a new data set, configure it, and drop it. So it could be just locations of sensors with temporal data, like traffic counts, and you can combine it with the floating vehicle data. That being said, you can also, of course, add your own background layers, your own GIS layers if you want in the platform.
Okay, thank you very much, Bart. Raghunath, again, so coming back to the data, people are asking now for the historical data, since when can the data be provided? So in terms of time.
Indeed, it depends on what type of data that we are looking for it. Because we started, if you look at the different data sets that we provide, that we have already our products, floating car data to the sensor data. Now, the floating car data sets, by default, we have the 2 years of historical data that we can provide. Also, it depends on the different regions because we have certain privacy rules of the data retention policies based on that. But you can, on average, say that we can go back easily 1 or 2 years from the date, and where it can be very useful for your analysis.
Okay, thank you very much, Raghunath. And then last question that I received, Bart, again, one for you. How is xyzt different from other data analytics tools for mobility?
Okay, well, yeah, so I think there's a couple USPs that we focus on. One and foremost is, of course, the focus on spatial temporal data, and that's where our name comes from. XYZ is location, T is time. That's the first. Second is scalability. The data sets typically can be quite big. We do allow interactivity on billions of data points to do your analysis. It's self-service. That's the third USP. It's bring your own data, so you can really use the platform not just with data from one specific data provider and then maybe also with another one, but also with your own data. And that's something we put a lot of focus on. And then the fourth USP is that we really cater to analysts. We really see a lot of open source tooling around data scientists, but we really cater to analysts who need to be able to quickly dive in, do their analysis, and don't want to lose time on coding, scripting, and so on.
Okay. Thank you very much, Bart. So this would be the end of our webinar today. So before we wrap up, I would still like to thank everyone who joined us today, and also everyone who asked all the questions. If you still would have any other questions, then please don't hesitate to reach out. As you see still on the screen, data-related questions can go to Bridgestone, platform-related questions can come to xyzt.ai. We will also send out an email after the webinar with the link to the recordings where you can reply to as well. And then last but not least, I would still say a big thanks to Bart and Raghunath for this very interesting webinar. And I want to wish all of you a nice rest of your day.